Good morning. Good morning to all of you. So, welcome to St. Clair's School online classes, children. Right, children. So, this is the wonderful opportunity to teach in front of you all the children through online classes, children. Right. I hope that you are utilizing this good information for your bright future. And students, once again, I am remind to all the students. See, please, all of you take care about yourself. So, right, children. So, please, all of you use the mask at your home, and you should use the hand sanitization. That means before I said SMS. That means here first of all you should use the sanitizing yourself, and you should use the mask, and the third one is you should maintain the social distance. Right, children? So these are the very important precautions because of. So today, according to the news channels, today our India reached the 6th position in the throughout our world. Right, children? So corona cases day by day it is increasing, children. So please all take care about yourself and take care about your family members. That is your responsibility. Okay, children? So let us come to the our IIT Chemistry. Children, so from few days onwards, from few days back onwards we have started one of the new concept regarding 9th and 10th classes. That is the concept, that is the atomic structure, children. Right? In the atomic structure we discussed lot of points. So what we discussed from last June 1st onwards to June 7 means we discussed lot of points, children, about introduction about visible and invisible particles. After that we discussed about what is electromagnetic radiation, and what we have the some electromagnetic radiations from sun to earth, and what is the source of those electromagnetic radiations, what are the applications. So these are the all points discussed in the last class. After that we discussed about what is meant by spectrum and what are the types of spectrum. Okay, children, and mainly we have discussed the spectrum in the classified into two types. Those are absorption spectrum and emission spectrum, and here absorption emission spectrum again classified into two types: continuous spectrum and discontinuous spectrum. And again discontinuous spectrum can be classified into two types: line spectrum and band spectrum. So like that we discussed a lot of points regarding spectrum also. Right, children? So why we need to discuss about spectrum is because of in case of discontinuous spectrum some wavelengths are missing, means in that missing wavelengths having some unknown particles. Those unknown particles were considered as atoms or molecule. That's why we need to study about what are those unknown particles, means we are considered as atoms. So we need to discuss about what is the structure of those unknown particles we consider as, that is the concept name is atomic structure. So two or more atoms combined together to form a molecule, those considered as a molecular structure. Right, children? So that's why we are introducing this is the concept. And in this atomic structure also we have discussed some points, children. What we discussed here to study about atoms, most of the scientists they done so many experiments like Democritus and Leucippus. These are the Greek scientists, they done so many experiments. But here before that only our Indian scientists, earlier Indian scientists, they gave some clues about atomic structure. That means atoms are indivisible, it can be present in the matter. Okay, they said only statement, that is statement was given by Kanada Mahasi. Right, children? After that one of the scientists, who is the scientist? John Dalton, he was studied about matter. Right, children? So he gave some postulates regarding atom. What is that? John Dalton atomic theory means what he said. So most of the matter consists of small particles. Those individual particles of a matter will consider as atoms. So the small particles of a matter will consider as atoms, and atoms are indivisible according to the John Dalton atomic theory. And the same type of atoms combine together to form a molecules. And suppose if we can take the same atom of the same element having same physical properties and chemical properties in all aspects. Different atoms from different elements having different physical and chemical properties in all aspects, and some of the same atoms having same atomic mass, but some of the atoms having different atomic masses. Like suppose if we can take calcium and argon. So here the atomic number of argon is 18, the atomic number of calcium is 20, but both are atomic numbers are different. Both the atoms are different from the different elements but having same atomic mass. Right, children? And next one is similar type of atoms combine to form molecules, but different types of atoms combine to form a compounds in a based on atomic weights in a simple ratio, right children? So these are all points we discussed in the regarding John Dalton atomic theory. And what are the demerits of John Dalton atomic theory means it does not explaining about the stability of the atom, and the second one is here different types of atoms combine together to form a molecule, but they are saying simple ratio. But here suppose if we can take carbon CO2, if we can in case of CO2 we have carbon C12 isotope, carbon C13 isotope, C14 isotope. In this particular case carbon dioxide does not maintain in any simple ratio, right children? So these are the some drawbacks in case of John Dalton atomic theory, and it does not explain here atom is divisible according to modern chemistry. But what he said, so atom is indivisible, right children? So that is comes under the John Dalton atomic theory. That's why it is failed to explaining about to study about matter or atom, children. So then thereafter here atom is divisible means what atom consists here. So what is the atom consist here means here atom consists of there are more than 100 particles are present in the atom, but in those more than 100 particles we have to consider the only three main fundamental particles. Those are electrons, protons and neutrons. Already we discussed about electron, proton. So for the electron, based on J.J. Thomson distributive experiment, we explained some characteristic properties of Thomson atomic model, and after that we discussed in the last class we discussed about what is the characteristic properties of cathode rays or anode rays. For the we discussing about protons, right children? After that we discussed here one of the concept in the last session, that is the Millikan oil drop experiment, and regarding from the Millikan oil drop experiment we discussed about what is the charge of electron and what is the mass of electron. So based on these two values we are finding the what is the mass of the proton, right children? So till now we are having information about electrons and protons. After getting the electrons and protons, we don't know about what are the remaining particles are there in the atom. So later one of the scientists, who is the scientist, J.J. Thomson only, he introduced the one of the atomic model. So what is the atomic model, children? Here suppose if we can take the atom consists of this is the totally, it is occupied by the positive charge. Based on the Thomson atomic model we are considered as a plum pudding model or watermelon model, children. See here in case of suppose if we can consider the watermelon means in case of watermelon what we have, so this is the total space it is occupied by the red pulp. So that red pulp he was considered as a positive charge. That pulp he was considered as a positive charge, and here the small seeds, black seeds, he was considered as a negative charged particles. That means when we are observing the watermelon, so we have more amount of red pulp is there and less amount of seeds are there. Children, was think about here more positive charge is there and less negative charge is there, means it is possible. So here atoms will be collapsed because of more positive charges are there, less negative charges. This means the possibilities are there to atom will be collapsed. Here atom is collapsed, children? No. That means here atom is not collapsed. That means the stability of the atom does not explained by Thomson atomic model. J.J. Thomson does not explain about stability of the atom, and he doesn't give the information about what is the exact position of electrons and what is the exact position of protons. He doesn't give any information about that, right children? That's why these are the some drawbacks are present in the Thomson atomic model, and he does not give the information about what is the center of the atom, or he doesn't give any information, children. So that's why it is failed to explaining about stability of the atom. Okay children, and here what are the another names of Thomson atomic model means watermelon model or plum pudding model or apple pie model, right children? So these are the points we discussed in the last class. Finally what we discussed here, children. So yesterday we discussed about to study about neutron also. So based on James Chadwick, he introduced the one of the concept explaining about neutron, that is he was considered the one of the alpha particles. He was bombarded with beryllium metal. Then we are getting the one of the carbon material along with one no charge material. What is the no charge material means? We are considered as a no charged particle. We are considered as a neutron. That means 1 0 and 1. That means 1 represent about atomic mass with there is no charge for the neutron. Right, children? So these are the points we discussed in the last classes, children. Okay, whatever it may be, here J.J. Thomson, he does not give an exact information about what is the position of the electron, what is the position of the proton, and what is the another information. So what are the drawbacks of the Thomson atomic model? This is the drawbacks can be worked on by one of the scientists, Rutherford. Who is the scientist, children? Rutherford. Here Rutherford, he was explaining about some postulates regarding atoms. So what are the postulates he was explained? I will explain now, children. Alright, children. So please, children, each and everyone, you should take your notebook and you should write each and every point in your CW. Okay, children. So please, all of you follow my classes, right, children? So now coming to the, I will explain about what is the Rutherford alpha scattering experiment. Rutherford alpha scattering experiment or Rutherford thin gold foil experiment. Thin gold foil experiment. Right, children? So this is the concept to consider as a Rutherford alpha ray scattering experiment or Rutherford thin gold foil experiment. Or directly both are same. Okay, children? So first of all, Rutherford, he was taken one of the particles, those are alpha rays. What, children? Alpha rays. I am already explained in the last class about alpha rays, children. So what is meant by alpha rays, children? Here alpha rays means, suppose if he was taken one of the lamp, that is the helium lamp. What, children? Helium lamp. Here helium consists of, the atomic number of helium is 2 and the atomic mass of helium is 4, children. See here, at helium having 2 electrons and 2 protons. After losing the 2 electrons, so then how many electrons are there, children? Here 0 electrons and 2 protons. Suppose if we can compare the electron number and proton number means, so what is the higher one, children? Here proton number is higher. So proton number is higher means what is the charge of proton? Positive. Right, children? See here, helium by losing 2 electrons, then it will get the charge, that is the helium plus 2. What, children? Helium plus 2. Helium plus 2 means what we are saying here? 0 electrons with 2 protons. 0 electrons with 2 protons. That means they lost the bit here, children. So what are the particles are present in the alpha particles? What are the particles are present in the alpha rays means? Option A, suppose they will give 2 electrons and 2 protons. Option B, 0 electrons and 2 protons. Option C, 0 protons and 2 electrons. Like that they will ask, children. So please all of you note this point, right, children? Here helium, that means positively charged particles of helium. Positively charged particles. Positively charged particles of helium is called as alpha rays, children. Positively charged particles of helium we consider as a alpha rays. Okay, children. So by using these alpha rays, Rutherford done one of the experiments, children. So what is the experiment done by Rutherford? I will explain now, children. Okay. See here, what is the Rutherford alpha scattering experiment means? Here Rutherford, he was taken the alpha rays in a lead chamber, children. In a lead chamber. See here, suppose it is the lead chamber, children. So in this lead chamber, here we have taken the one of the emitting light, that means alpha rays. What is that? Alpha rays. Here alpha rays emitting through the lead chamber. Then he was arranged the one of the slit. What is the, children? Here one of the slit. See here, these are the alpha rays are scattering on the one of the thin gold foil. Thin gold foil. See, children. So what is the thickness of or thin of this gold foil means? More than 100 nanometers, children. How much it is? 100 nanometers. And here this is the thin gold foil. He was closed with one of the zinc sulfide fluorescent screen. Zinc sulfide fluorescent screen. See children, so this is the screen we consider as a zinc sulfide fluorescent screen. Zinc sulfide fluorescent screen. See children, see here, this is the fluorescent screen. What is the usage of this fluorescent screen means? It does not observe any radiations. It does not observe any radiations. It can be completely what is observed by this screen. The total number of radiations will be emitted again. And similarly, here what we are taking here, this is considered as a lead chamber. What children? This is considered as a lead chamber. So here in chemistry what we call here plumbum. So plumbum is the Latin name and here our general name is lead. Okay children, here consider as a lead chamber. In that lead chamber what we can do here children? So through in that lead chamber is the source of the alpha particles. Source of the alpha particles. When we are sending the alpha particles through the one of this thing, so these are the alpha particles are scattering on the thin gold foil. Scattering on the thin gold foil. Children, in this these are all consist of gold atoms. What is those are? All are gold atoms. Suppose if we can consider one gold atom, see here this is the one of the solid thin gold atom. Okay children, so this is the one of the atom of gold. So what is the representation of gold children? Rm. Okay, see here, so these are all many particles are there in the atom. So in that atom, what we are sending here children? We are sending the alpha particles. See children, when we are sending the alpha particles, through the thin gold atom, thin gold foil of gold atom is here, most of the alpha particles, it will be travel in a straight line. Most of the alpha particles can travel in a straight line. So most of the alpha particles can be travel in a straight line means what we have to conclude here children means, here we have to conclude that, so suppose if we can keep the torch light in front of you, when you keep it on the any wall, so what we had observed here, we had directly the focus of the light we had observed on the that white wall children. So but here same thing, when I am sending the alpha particles through the thin gold foil means most of the alpha particles can travel in a straight line. That means there is no particles. Based on that what we have to say children, here most of the space in an atom it is the empty. Most of the space in an atom is empty children. So that is the first postulate about Rutherford atomic model children. What is the first postulate children here? Most of the space in an atom is empty. Most of the space in an atom is empty. So this is the first postulate of the Rutherford atomic model children. And here suppose when you are sending the alpha particles means approximately we are sending here 20,000 alpha particles children. How many particles we are sending here? We are sending the more than 20,000 alpha particles we are sending through the thin gold foil. Right children? In those 20,000 alpha particles, some of the alpha particles are, it will be deflected from its original path. Why it is deflected? Or why it is deviated means, see children, suppose if we can observe here, see here, when we are sending the most of the alpha particles through the thin gold foil means, here most of the alpha particles are traveling in a straight line, but in those 20,000 alpha particles, some of the alpha particles are deflected its path by the angles of 60 degrees and like along with 120 degrees angles and with 90 degrees. Like here, some of the alpha particles will be deviation of the path will be takes place. Why the alpha particles are deviated from its original path means because of some particles will be there. So what are those particles means here children? So when the alpha particle is scattering through the thin gold foil. Suppose one of the particle is there means what is the particle here children? That is the electron. So what is the charge of alpha particles? The charge of the alpha particles is positive. Why? Because of here I am said positively charged particles of helium we are considered as a alpha particles. That's why what is the charge of alpha particles children? The charge of alpha particles is that is the positive. The charge of the alpha particles is positive. And what is the charge of electron here children? Negative. So positive and negative attraction will be takes place. That's why the path of the electron, the path of the alpha rays is deviated. And similarly, suppose when you sending like here, most of the alpha particles will be, what will happen children? The path of the alpha particles are deviated. Okay, with the angles of 60 degrees, 90 degrees and 120 degrees angles children. And here in the few of the alpha particles, see children, so few of the alpha particles, so among those 20,000 alpha particles, one of the particle here, it will go in a straight line and it comes back with the angle of 180 degrees. One or two particles of alpha ray. One or two particles of alpha ray will be comes back with the angle of 180 degrees. So why it is comes back with the angle of 180 degrees? Why children? Did you know the reason? Why it is come back here? Why? Because of here what we are saying here, the charge of alpha particles is positive. So the charge of alpha particles is positive means electrons will be attract to each other. But here suppose if we can take the small space of the center of the atom, it is comes back with the angle of 180 degrees means because of it will be repulsed to that particle. So what if it is repulsed to that particle means it is considered as a positive charge. It is considered as a positive charge. The charge of alpha particles is positive. The charge of the center of the atom is positive. Positive and positive means repulsions will be taking place. So positive and negative means attractions. But here positive and positive means repulsion will be taking place. Here the center of the atom, it is consist of positively charged particles are located at the center of the atom. So that location we consider as a nucleus of the atom. What you mean? Nucleus of the atom. See here, center of the atom considered as a nucleus. So nucleus consists of positively charged particles. Which are the particles we have? Some positively charged particles, children? We have protons having positively charged particles are there. That means the center of the atom consists of positively charged particles. That means protons and neutrons. Protons and neutrons can be present in the center of the atom. We are considered as a nucleus. So based on this, what we are saying, children? So nucleus is introduced by Rutherford. Nucleus is introduced by Rutherford. Okay, children. See here. Suppose if we can consider that it is the radius of the atom. Radius of the atom. Already we discussed with the periodic properties in 7th class. We discussed here. That is the point. Here the distance between nucleus of the atom to the radius of the total valence shell of the atom we consider as a radius. The distance between nucleus to valence shell of the atom considered as a atomic size or atomic radius. See children, in case of atomic size here, we are expressed in terms of angstrom units. One angstrom unit equals to 10 to the power of minus 8 centimeters. 10 to the power of minus 8 centimeters. But here, the size of the nucleus, the size of the nucleus is 10 to the power of minus 13 centimeters. Children. Here, 10 to the power of minus 8 centimeters considered as a atomic size. And here 10 to the power of minus 13 centimeters considered as the size of the nucleus. Size of the nucleus. See children, the size of the atom is 10 to the power of minus 8 centimeters. The size of the nucleus is 10 to the power of minus 13 centimeters. When you convert it into meters means here we are getting 10 to the power of minus 10 meters. Here we are considering 10 to the power of minus 50 meters. See children, what is the difference between the size of the atom and the size of the nucleus means here 10 to the power of minus 8 centimeters, that is the size of the atom. Here 10 to the power of minus 13 is the 13 centimeters is the size of the nucleus. nucleus. What is the difference here, children? So the difference is 10 to the power of 5. What is the difference, children? 10 to the power of 5 centimeters. Here, when comparing the size of the atom and the size of the nucleus, the size of the atom is 10 to the power of 5 times is greater than the size of the nucleus. What is the, children, here? What we conclude here? The size of the atom is 10 to the power of 5 times greater than the size of the nucleus. So based on that, what we had concluded here, the size of the atom is more than the size of the nucleus. Okay, children. So this is the one of the important point we are getting from the Rutherford alvarez scattering experiment. So what we have to telling here means, actually what we are saying here, children. So this is the Rutherford alvarez scattering experiment about atom we are saying. But it is this is the experiment is useful for finding the nucleus of the atom, children. Okay. So these are the points can be explained by Rutherford. Okay, children. See here once again I am explaining here. The first one is most of the space it is empty in an atom. Why? Because of most of the alpha particles can travel in a straight line, means the most of the space in the atom is empty. And the second point, some of the alpha particles will be deflected its wave because of here some particles will be present here. And here third one, the most of the alpha particles can be travel straight line, but one or two particles it comes bounce back with 180-degree angle, means here the center of the atom consists of positively charged particles that we consider as a nucleus. Right, children? So these are the points we are learned from the Rutherford atomic model. And here what is the size of the atom, children? Here the size of the atom is 10 to the power minus 8 centimeters or 10 to the power minus 10 meters. And what is the size of nucleus, children? 10 to the power minus 13 centimeters or 10 to the power of minus 10 to the power minus 15 meters. Okay, children, what is the difference between these two means? What is the difference between here? What is the difference between size of the atom, size of the nucleus is 10 to the power of 5 times. How much, children? 10 to the power of 5. So this is the, based on this what we are saying here, the size of the atom is more than the size of the nucleus. Here also some drawbacks are there, children. So what are the demerits or what are the drawbacks of the Rutherford atomic model means? See, children, according to the Rutherford atomic model, see here, all the electrons can be revolved around the nucleus. All the electrons can be revolved around the nucleus. So he was taking the one of the help of our solar system. See, children, in our solar system also, the center of the solar system are considered as the sun, and the remaining planets can be revolved around the sun. So by using some forces, forces. So what are the forces we know about according to our solar studies? But here, suppose in our solar system, what we are saying here, center is the sun is the center of the solar system. The remaining all the planets can be revolved around the sun in a particular path. Similarly, suppose if we can take the atom also, here center of the atom considered a nucleus, the remaining electrons can be revolved around the nucleus in a particular path, children. See here, according to the solar system, if the total electrons can be revolved around the total planets can be revolved around the sun, means sometimes if it is continuously revolving around the sun, means according to the modern physics, it wants to lose some energy. If it wants to lose some energy, means it comes to the sun, the solar system will be collapsed. It will happen here? No. So same thing here also. When the electrons can be continuously revolved around the nucleus, so the electron does not come closer to the nucleus. It does not come closer to the nucleus, means here atoms will not collapsing here, children. Atoms will not collapsing here. That means here he does not explain it about why the electron does not emit the radiation, why the electron does not lose its energy. If it can lose its energy, means it wants to come closer to the nucleus, then the atoms will be collapsed. That means it will not happen in the particular case. That means based on that, what we are saying here, the stability of the atom does not expand by Rutherford alvarez scattering experiment. That is the first drawback of the Rutherford alvarez scattering experiment, children. What is the first drawback here? here, the stability of the atom does not explained by Rutherford alpha-ray scattering experiment. Okay, children. So now coming to the what is the second drawback of the Rutherford alpha-ray scattering experiment means here. Electrons continuously revolve around the nucleus means continuously emits the some radiation. If it can continuously emits the radiation means sometimes what we are getting here, we are getting the some spectral lines will be happening here. That means here the continuous spectrum of the lines, it does not explained by Rutherford alpha-ray scattering experiment, children. Okay, so the first one is Rutherford does not explaining about stability of the atom, and the second one is Rutherford does not explain about continuous lines of the spectrum. Okay, right, children? So these are the two drawbacks of the Rutherford alpha-ray scattering experiment. And here what we are saying in one point here, it was correlated with our solar system. That's why this is the Rutherford alpha-ray scattering experiment, also called as planetary atomic model. Okay, children. So this is about what is meant by Rutherford alpha-ray scattering experiment. Okay, children. So in this concept, we discussed lot of points. Okay, children. So please, all of you know these all points. So you should maintain the notebook, and you should, if you have any doubt, means you should revise the video and you should note the points. If you have any doubts, you should ask me through WhatsApp. Okay, children. So we'll get tomorrow by the next class. Okay, children. Thank you.